Hi class and welcome to this virtual lecture. My name is Ramon Torres, your instructor, and in this opportunity we will be discussing matter and energy. Let's see some objectives for this lesson. We will discuss what is matter, what are considered mixtures, different types of mixtures. We will discuss the states of matter, the changes that matter undergoes, the effect of heat on matter molecules, and also changes of state. Let us begin by defining matter. Matter could be defined as anything that has mass and occupies space. Now, to understand matter, we also have to understand the term of a pure substance. And this is matter that has a fixed or a definite composition. In this case, we will be discussing two different sides of pure substances. The first one is what we consider an element. An element, it's composed of only one type of material. It's made of only one material. And examples for this will be a substance made entirely of iron, copper, gold, or carbon. On the other hand, we have what we call compounds, also a pure substance but consists of two or more elements. Some examples would be water, H2O, oxygen peroxide, H2O2. These are some examples of many compounds found in nature. When we are identifying between an element and a compound, it is very important for us to keep an eye on the formulas. If the formula only has one element, it is considered to be an element. If the formula has two or more elements, then it is considered a compound. The other different type of matter that we can find is what we call a mixture. And a mixture, it's two or more different substances that are physically mixed, but not chemically mixed. It means that the different parts of the mixture still retain their original properties. Mixture could be subdivided into two categories. A homogeneous mixture, which is the composition, it's uniform throughout the sample. Examples of this would be air. We cannot see different components of air. Seawater. When we looked at seawater, we can just see the water. And milk. Even though it's composed of several molecules, we can only see a smooth white surface. A heterogeneous mixture, on the other hand, the components do not have a uniform composition throughout the sample. Some examples of this would be a cookie with raisins, and we can identify the dough from the raisins. A delicious pizza, in which we can see the pepperonis and the cheese. And pulpy orange juice. We can see the juice, but we can also see the little pulp floating inside of this juice. In here we have a chart that is going to help us organize all this knowledge that we have been talking about. We have atoms, and atoms, when they join together, they form molecules. Now these molecules, they make up all types of matter. And all types of matter, we can have them have substances or pure substances and also mixtures. The substances can be divided into elements and into compounds. And in the example, we have gold, which is entirely made of gold. In the compounds, we have a glass of water, and it has water molecules, just one type of molecules. And we also have salt, that it's made entirely of salt molecules. In the other hand, we have the mixtures. And the mixtures, as we said before, we have the homogeneous mixture that are made of two or more different things, but we cannot see the different parts. For example, in this little piece of jewelry here. And we have the heterogeneous. In this dirty pan that we have here, we can see that there are different molecules, so we can distinguish one from another. Let's talk about the different states of matter. And this is not a new topic, as we have been seeing this for many years. Matter, we can find it in three different states. We have solids, we have liquids, and we also have gas. A solid could be defined as a substance that has a definite shape and also a definite volume. Liquid, it has a definite volume, but it does not have a definite shape. The liquid takes the shape of the container that it is in. A gas neither has shape or volume in a definite form, meaning that the gas will take the whole area of the container that it's keeping it together, and it will also take the shape of that container. To understand matter, we have to talk and discuss about physical changes and chemical changes, and this is a way in which matter interacts with other elements in our world. Physical properties are those characteristics that can be observed or measured without affecting the identity of a substance. For example, the shape of the substance, its color, its melting point. Physical change, its state, its size, or appearance will change, but the composition will remain the same. And some examples of this would be boiling water. Its state will change. It will turn into a gas, but it will still be considered water. If we dissolve salt in water, it disappears in front of our eyes. But if we boil that water away, all the salt crystals will reappear in front of our eyes. On the other hand, chemical changes. Chemical properties are those that describe the ability of a substance to change into a new substance. The chemical change involves that the original substance is transformed into something completely new, with a new composition. And an example of this would be rust in a nail. We have iron, and when it reacts with oxygen, it forms a completely new way of iron, an oxidized form of iron, therefore changing its structure, its chemical composition. This is a great example of a physical change. We saw the piece of glass hitting a surface, breaking into 1,000 million pieces. And each one of those pieces still remain the same properties as the original piece of glass. Therefore, it's a physical change. In other example, we have wood burning. In this case, the reaction of combustion of the fire, it's transforming the wood into brand new different substances, including pure carbon, including carbon dioxide, and many, many others. And this change from wood into something completely new is what we call a chemical change. Changes involve energy, and energy can be defined as the ability to do work. Now let's divide energy into two different types of energy. In one hand, we have what we call kinetic energy, or the energy of motion. When something is moving, it's using kinetic energy. On the other hand, potential energy. It's determined by the position of the object, of the chemical composition. This is energy that a substance has when it's showing no movement. Let's see an example of this. Let's say we have a mountain, and on top of that mountain, we put an enormous boulder. When this boulder is not moving, it is showing off potential energy. The moment that boulder starts to move, we are expressing kinetic energy. When the rock stops at the bottom, all that kinetic energy is no more. And once again, it is showing potential energy. Energy could be related with heat. Now, heat makes molecules move faster and faster. The more heat, the more faster movement we're going to have on those molecules. Now, in solids, molecules barely move. They just vibrate. In liquids, molecules do move, but they move slowly. In gas, molecules move really, really fast. And this is the cycle of matter. Let's start giving some examples by talking about solids. In the solids in this picture, we can see that the water molecules are arranged in a crystalline structure. And that crystalline structure prevents molecules from moving freely around the substance. As we apply heat, the solid begins to melt, meaning that the molecules are going to start moving more freely, but still very, very slowly. If we continue to add heat to the liquid, it's going to start to vaporize, meaning that the molecules in the liquid are going to start moving faster and farther away from each other until we cannot practically see these molecules like happens with gas or water vapor. Now, this process can also happen in a different way when we are removing heat from substances. When we start removing heat from a gas, the molecules move closer and closer to each other by a process called condensation. And then we have a liquid. If we start removing heat from this liquid, eventually the molecules are going to rearrange one more time into a crystalline structure by the process of freezing, moving from a liquid once again to a solid. Now, solids can move directly to gas, and there are different properties or different things that have to happen in order for us to observe such a phenomenon. But let's say we're talking here about an enormous amount of heat applied to a solid. The crystalline structure will automatically break by the process called sublimation and go directly from a solid to a gas. On the other hand, if that gas it's exposed to a rapid removal of heat, those molecules will redeposit by a process called deposition, and the gas molecules are going to automatically turn into a solid. That have been all for this virtual lesson. I hope that this has been of enjoyment for you, and I will see you on the next one.